Hey there, space enthusiasts! Whether you're a seasoned astronomer or just someone who loves gazing up at the night sky, today's story is sure to spark your curiosity. Today, let's dive into the cosmos and explore a recent hiccup from the marvel of our time, the James Webb Space Telescope, or JWST. This incredible observatory is humanity's most ambitious eye on the universe, peering deeper into space than ever before. Specifically, we're talking about the MIRI, or the Mid-Infrared Instrument, which encountered a bit of a glitch in August 2023. MIRI is one of JWST's 4 main scientific instruments, and it's crucial for capturing the faintest heat signatures from distant galaxies, stars, and even exoplanets. But don't worry, it's not the end of the universe as we know it. Space missions are full of surprises, and the JWST team is always ready to tackle them head-on. So what exactly happened with MIRI? MIRI experienced reduced light in one of its 4 observing modes. This means that for a specific way of looking at the universe, the instrument wasn't getting as much data as expected. Think of it as having a camera with a minor lens smudge. Your photos are still good, but maybe not quite as crisp in one corner. For astronomers, even a small change like this can make a big difference in the data. NASA assures us that while it might slightly affect exposure times, the science powerhouse that is JWST remains largely unaffected. Good news, right? The telescope is still delivering breathtaking images and groundbreaking discoveries. Now let's talk data. The JWST's complex data pipeline isn't without its quirks. Processing the vast amounts of information from deep space is a monumental task, involving sophisticated software and careful calibration. Errors can sneak in due to issues with the World Coordinate System, which helps pinpoint exactly where the telescope is looking in the sky. It's like misplacing your Google Maps pin by a hair's breadth, but in space terms, that's up to an arcsecond. In astronomy, even the tiniest misalignment can mean missing a distant galaxy or a faint star. And cosmic rays? These high-energy particles zip through space and can leave behind snowballs or bright spots on detectors, creating artifacts in the images. Most of these get cleaned up automatically by advanced algorithms, but sometimes, a manual touch is still needed to ensure the data is pristine for scientific analysis. And then, there are micrometeoroid impacts. These tiny, fast-moving dust particles are an ever-present hazard for any spacecraft venturing beyond Earth's atmosphere. These tiny dust particles occasionally play dodgeball with Webb's mirrors, sometimes leaving behind minuscule marks that can affect the telescope's performance. Back in May 2022, one such impact left an impression on segment C3, a small but permanent reminder of the harshness of space. Fortunately, NASA's got some clever folks who used mirror actuators to compensate, adjusting the mirror's shape to keep the telescope's vision sharp. These impacts happen about once or twice a month, and mission planners now steer clear of high-risk zones, carefully plotting JWST's observations to minimize future damage. Finally, let's not forget about instrument electronics and power anomalies. Even the most advanced technology can experience hiccups when exposed to the extreme conditions of space. Space is an unforgiving environment filled with radiation, temperature swings, and debris. All of these can challenge the reliability of even the best engineered systems. But rest assured, the JWST team is on it, keeping a close eye on all systems and ready to respond to any anomaly, big or small. So, what does all this mean for space exploration? It shows us that exploring the universe is never easy, but it's always worth it. It's a testament to the incredible resilience and ingenuity behind the JWST mission. Every challenge faced and overcome is a victory for science and for humanity's quest to understand our place in the cosmos. Each challenge is another opportunity to learn and adapt, pushing the boundaries of what we know about the universe. The lessons learned from JWST will shape the future of space telescopes and inspire the next generation of explorers. Thank you for joining me on this cosmic journey. The universe is vast, mysterious, and full of surprises, and together, we're just getting started. Remember, space exploration isn't just about reaching for the stars, it's about solving the puzzles they hold, one discovery at a time. Until next time, keep looking up, stay curious, and never stop exploring the wonders of our universe.